Hi, so for this question, I had to think a bit. So let me show you my first not so efficient approach. Number one, you need to realize that these are all 1 centimeter cubes, right? 1 centimeter cube. So it's really just 1 cm cube, cubic centimeter. Here we put square, something wrong with your units, okay? Then you have 144 of these blocks, so you want to build it up into a perfect cuboid, okay? Perfect meaning you don't have any like dents, any missing cubes or anything. It's just a perfect cuboid that's fully filled, meaning you can just find its volume by taking length times breadth times height. Oh, so they tell you that he arranged all of the cubes into a cuboid. Perimeter of the top of the cube is 22 cm. So the length, and each of the length has to be greater than 2 cm. So you want to find the height of the cuboid. So let me show you my first approach, which is wrong. Yes, first step is to prime factorize 144 into 2 power 4 times 3 square, and then you realize that, oh, it must be perfect cuboid, so length times breadth times height. So something multiplied by something multiplied by something. Right, I need to split these factors into 3 separate groups. Okay? But then I also know that the perimeter of the top of the cube is 22 cm. Oh, okay, so that means that if I have my cuboid like this, that's my top. I can label these these sides, which are blue color, maybe I'll call them letter X, call it X and X. Then the other side will be Y and Y. By symmetry, opposite sides of a rectangle must be the same. So that means that 2x plus 2y must equal to 22. Then you can just factor out the 2 and divide by 2 on both sides. You get 1x plus 1y equals to 11. And I also realized that, hey, each length is also more than 2. So it means, because we're using cubes, right, which are whole numbers, so it means that the minimum length must be 3. Okay, so I work with this information. Thus, 2 lengths are one of the length, the breadth, and then the height. The length plus the breadth must be equal to 11, and I know each of them, the x, the y, has to be more than 3. So what I did is I proceeded to list out every single possibility where I start off with my 2 power 4 times 3 square. I consider 2 power 1, and then I split into 2 other factors to all the possibilities. I realized 2 power 1 too small because you need at least 3, so we get rid of that case. Oh, it's too small. And then I consider 2 square. After 1 is 2, so consider 2 square. Then I split into every single case, and then I check them one by one. Does it satisfy this condition? No, none of them satisfy this condition. Or it will be the case where some of them the length exceeded 11. Or maybe another rule you can add in is x and y must both be less than 11, right? You cannot have 11 for x, then that must mean that plus y must be 0 to get 11, and that doesn't make sense. You can't have a length 0. So there's this other rule, each of them has to be less than 11. Then I check through every single one of the cases, and I realize that, oh, there's only one that works out. There's only one that works out. When you have one length 2 cube, a length 2 cube, a length 2 times 3, 6, and a length 3, 8 plus 3 gives you 11. So that's the only one that works. Okay, then let's see. So what this means is you have your cube, here's length 8, here's length 3, then the remaining length is 2 times 3, 6. So your answer is 6. Okay, this during exam condition is almost impossible to do. Listing out every possibility and checking one by one, too slow. So here's a better method. What we need to do is a better method. Still the same thing, we need to do the prime factorization. Okay, prime factorization, know that we need to split it into 3 factors. Still need to do the same procedure. Maybe I'll just label here x, y, x, y, y, x, y. Or maybe I show a bit of the working. Here what's going on is I factor out the 2, so I get 2 times x plus y equals 22. Then I just divide by 2. X plus y equals 22 over 2, which simplifies to 11. X plus y equals 11, this guy. Okay, what you need to realize actually is to go a bit further in this argument. They say that each length is more than 2. It means that at least each of them is 3. That's your first, first clue. But you can go further from this point number 1, from this statement number 1, that each length must be 3. How about we list down every single possibility of 2 numbers add together to get 11? That's definitely faster than listing down every single possible way of multiplying 3 numbers together, right? So that's what we're gonna do. We're gonna show, so here's the 3 ways. Okay, it's because each of them must be at least length 3, so we start with length 3. Then 11 minus 3 must be 8, so 3 plus 8. Then we consider the next possibility after 3, must be a 4. Then 4 plus something gives you 11, must be a 7. Then the next number, 5 plus 6 must be 11. Okay, so these are the three ways. But wait, you think, how about the other direction? How about the other direction? Let me just review. Yeah, how about the other direction? You swap them around. 8, 3, 7, 4, 6, 5. Does it matter? No, it doesn't matter. No, it doesn't matter. Because they only tell you that it's the top length. Sorry, what do you call it? What do you say? The perimeter of the top of the cuboid, right? The top of the cuboid, now they never specify which one is length, which one is breadth. So it doesn't matter. You swap them around, the order doesn't matter. So we only got 3 cases. So maybe from there we can go on and continue listing down all our ways? No, don't do that. We have to think a bit more. Here, when you have the 3 plus 3 and the 8, the 4 and the 7, the 5 and the 6, I highlighted the 5 and 7. Why do you think I highlighted it? Okay, it's because what's really going on is this 3, this 8 is really just telling you the length and the breadth, or x and y, it doesn't matter which order it is, length and the breadth of the top. And in order for the length or the breadth to be one of these numbers, it has to be one of the factors of these guys, right? One of the factors of these guys. And I hope you know that when you try to split this, when you prime factorize it and you try to split it up, you can only get 2 power something, 3 power something in each of these places, right? 2 a prime number to a power of something, 3 another prime number power of something. You cannot have like extra 5 power something or 7 power something. That cannot divide into the 144. It doesn't divide the 144 nicely. So what does that mean? What does that mean? It means that other prime numbers other than 2 and 3 cannot be the lengths of the top of the cuboid. You get what I'm saying? Okay, I hope you can understand. So after 2 and 3, it must be a 5, must be a 7, the prime number, right? So let's take a look. 5 and 7, right over here. So what this means is that for these 2 cases where you're considering the top of the perimeter, one of them is side length 4, side length 7, it's impossible. Why? Because if here is 7, here is 4, can we find out the last length? Yes, we can. We can just take 144, divide by 4, divide by 7. What do you realize when you try to divide by 7? Divide by 4, okay lah. 144 divided by 4 is really just 36, so 36, but you still gotta divide by 7. But the moment you try to divide by 7, that's a decimal. 5.144, 5.1428. Impossible. Not allowed, because we're building this cuboid using 1 cm cubes only. So this 7 is impossible because it's a prime number. Likewise with your 5. Likewise with your 5. If you take 144, sorry, let me just present it nicely. Likewise with the other case where it's 5, 6. What this 5, 6 refers to is the case where you have the top of the cuboid, the length and the breadth 6. So the remaining height, what is it? It must simply be 144 divided by 5, then multiplied by 6. Divide by 5, then divide by 6. If you divide by the 6, it's okay. 144 divided by 6 is 24. But the moment you try to divide by 5, you will introduce decimals. You will introduce decimals, 4.8, which is impossible. You cannot have 4 cubes and 0.8 of a cube. You take a cube, chop it up into 10 equal slices, and then you take 8 of those slices. No. That's not what they're saying. You cannot slice the cube up. 1 cm by 1 cm by 1 cm cube, you cannot slice it up. It's like an atom. Okay, so this also impossible. So what this means is that these 2 cases have been eliminated, which means that we're only left with this case, which means that our only possibility, based on the fact that each length is more than 2, meaning must be minimum 3, we listed out all 3 possibilities, and the fact that they add up to 11, by elimination of the prime number lengths 7 and 5, we concluded that there is only one possibility for our top. One of them must be side length 3, one of them must be side length 8. Right? Good. So what can we do to find the height now? How do you find the height? Given that you know one is 3, one is 8, and the total volume is 144. You just have to divide 3 by 8. So what do we get? 6. Then that's our answer. Very, very simple. If you stop to think a bit, what does something plus something equals to 11 mean? It means these 3 cases. But what does it mean for you to be a length? It means you have to be a factor of these guys. You can only have prime number 2 and 3. 2 power something, 3 power something. The length of the x and the y must be expressed as 2 to the power of something times 3 power something. Cannot have other prime numbers. 5 and 7 are the weird odd one outs. They are not you cannot rephrase it as you cannot rewrite it as 2 power something or 3 power something. So these two cases where it's length 4 and 7, where it's length 5 and 6, they're out. You're only left with this one single case, which means that it's very easy. You already know the length 3, you already know the breadth 8, then you can just divide to find the height. And for the volume, divide by the length and the breadth to get our height, length 6.